All right, we're back. Welcome once again to another episode of Howdy Partner. My name is Andrew Park, and I'm a partner solutions architect here at AWS. And with me, we have some new friends that haven't been on the show yet, but some friends that you should know about, especially if you're interested in things like Kubernetes, security, DevOps, all that good stuff. So in this episode, we're going to be talking a lot about security and observability specifically within Kubernetes. And so, with that said, I have a new co-host today, and this is actually her first time on stream. So welcome, my colleague and fellow SA, Gitika. Gitika, do you want to introduce yourself?
Yeah, thanks so much, Andrew. Hi, everyone. I'm Gitika. I'm also a partner solutions architect with AWS. Been with AWS for almost 3.5 years now. Really loving the journey, and we are really excited to have Tigera with us. And I'm really excited about this episode.
Yeah, and so for those of you that may not be familiar with what a partner solutions architect does, basically we work with our ecosystem of partners that basically support the AWS ecosystem of services. And so this could be database related, this could be focused on containers, this could be focused on basically any other AWS service that you can think of. But basically, it's our job to work with our partners to help build relationships that support our ecosystem. And so, like I mentioned before, today is going to be all about security and observability within Kubernetes. And this is something that Tigera does very, very well. And funny backstory is when I was kind of learning the ropes of containers and Kubernetes, what was it? Tigera's open source project, Calico Cloud, is actually the way I kind of started learning about network policies and kind of what security and observability really means within Kubernetes. And I think it's really important to know about these different products within the market because these are the types of services and projects that will make your life so much easier, especially as your organization expands into something like Kubernetes. So make sure to pay attention. Make sure to ask questions in the chat about anything Kubernetes related. And we'll do our best to make sure we're answering your questions. But if this is your first time hopping on the show, we're here every Tuesday at 2 o'clock Pacific. So make sure to subscribe for weekly updates because every week we're looking to have new partners on the show. But I guess to kick things off, when you think about the Kubernetes landscape, it's pretty broad and deep. And if you've ever looked at the CNCF map of projects that have graduated into the ecosystem, it's pretty overwhelming. And I'm sure both my friends Nigel and Amit can also adhere to that. And that it can be really overwhelming, especially when you think about the various security and observability tools that you can choose from. It can get kind of difficult. And so I think what my friends Amit and Nigel are going to talk about today is kind of how Tigera helps us solve that problem. But I kind of want to paint this picture before we get into that, because I think there's this misconception about Kubernetes where, once you deploy your first cluster, like everything's set for you, it's secure by nature. You have all the observability capabilities that you need, but in reality, it's actually not that simple, right? And when you think about, especially in situations where you have to manage multiple clusters across multiple different clouds, maybe you have like a hybrid setup, these problems become much more complex and much more difficult to solve if you're not using something like Tigera to help you solve these problems, right? And so let's think about it this way. So if you have a Kubernetes cluster, right, there's a lot of things you need to think about in terms of locking down that cluster. When we think about access management, what does DNS security look like? How are you making sure that certain services can only talk to other certain services? And the deeper you go into the Kubernetes stack, this particular problem gets very, very complex. And so if you think about the standard example of if you have one pod that needs to talk to another pod in different namespaces, what does that solution actually look like and how difficult is it to do that at scale? And so when you think about especially folks that need to adhere to like regulatory requirements and like financial services, like healthcare, these are like a must-have. And if you don't have an answer to solve these problems, there's a pretty good chance that your organization or your team is probably not going to adopt something like Kubernetes because you have to be able to answer to these questions. So I think, understanding the different options that you have for observability and security within your Kubernetes workloads is really, really important. And more than anything, I think it almost becomes like a governance issue, right? Because when you think about all the different users, workloads, and applications that you need to manage at scale, you need a way to provide you that visibility that you need, especially if something goes wrong, if something fails, if there's a security vulnerability. Like you need a centralized dashboard to kind of help you view all these things in real time. And so I think with the product Calico Cloud that was developed by our friends over at Tigera, I think it helps us solve each one of these issues, which is security, observability, governance, and a combination of all three, quite honestly. And so that's kind of the background, the picture I really wanted to paint, so that when we start talking about the different concepts in today's show, it'll make more sense, especially in the context of Kubernetes. But with that said, I'd like to introduce my new friends Amit and Nigel from Tigera. Welcome to the show.
Thank you, Andrew. Really excited to be here and looking forward to the show today.
Cool. So tell us a little bit more about Tigera, kind of what you guys do, what problem you guys are looking to solve. Tell us a little bit more about yourselves.
Absolutely. So, Andrew, as you mentioned, when folks start with Kubernetes, usually things are pretty straightforward and simple. But as you start putting in more and more workloads into your Kubernetes environments, things get a little bit more complicated, primarily because it's a very scalable, distributed infrastructure. And that's really, it leads to some very specific security, compliance, observability, and governance issues, as you mentioned. So Tigera primarily is in the business of solving those environments. And today, Nigel and I are going to walk you through some very specific problems that we are seeing most folks run into as they deploy those workloads in the Kubernetes clusters. And we'll walk you through what we have designed as a pattern and also best practices on how to address that. So Nigel, I'll let you introduce quickly and we'll jump right into the discussion.
Yeah, no, my name's Nigel. I'm a solutions architect here at Tigera. I do work with open source Calico, but I'm primarily assisting organizations as they're making that transformation to maybe taking our open source CNI for networking or the network policy implementation and kind of getting them on board with our enterprise technologies as well. So hopefully someone out there who's enjoying this session today might see some of the use cases and they might resonate with their organizations.
Thank you, Nigel. So I'm Amit Gupta. I run product management and also our partnerships. And here's a quick roadmap for our show today. We'll start with a little bit of introduction about Tigera, who we are, what problems we solve. And then we'll go through some real world scenarios, some stories that we have seen and learned from working with our users. And then we'll talk about how to address those. And I promise you that I'll do less of talking and Nigel will do most of the work here. He does a phenomenal job in walking through how this works. Now, for all those AWS builders who want to follow along with us, this is a true hands-on experience. I have a bit.ly link posted here. And if you want to actually follow along with us as we talk about various things and capabilities, I recommend you get started right away. So go ahead and get this link from the chat and sign up. What it will do is it will give you access to Calico Cloud that Andrew talked about. And if you have your own either EKS clusters or any self-managed dev test environment that you want to connect to this Calico Cloud and want to play along, you can do that. If you don't have a cluster available, don't worry about it. This environment comes with a sandbox environment where some kind of sample apps and some applications are already deployed. So you can play along with us to get familiar with this. But I strongly recommend if you have a cluster, go connect it. That will give you a little bit more realistic experience with your own dev test environment, your own applications. And we'll follow along through the show and answer any questions you may have. But if you have any further questions, feel free to reach out to us. Here's an email address that you can reach out to for any questions, anything related to what we talk about today or anything that Tigera does. So with that, and again, I'll encourage you to go sign up, get started. But with that, we will just kick it off. So for those folks who are not very familiar with Tigera, we're actually the inventors and maintainers of Project Calico, founded about 5 years ago, and very proud and very blessed to say that we are the most adopted Kubernetes open source networking and security solution, to the fact that we can say that there's more than 1.5 million nodes today that are powered, secured, managed through Calico. And if you just play that in terms of workload, tens of millions of workloads are being connected or protected across the planet using our open source technology. So very proud to have the ubiquity we have in the market. There are various reasons why users like yourself choose Calico. But one of the main reasons is that Calico is designed to be a very pluggable data plane architecture. What that means is today, if you're starting with some Linux workloads in your Kubernetes environments, containerized environments, and then tomorrow for specific use cases, you want to move to modern kernels and have some high performance requirements. You're deploying an eBPF data plane, you could choose Calico for that as well. And then as your workloads evolve, and suddenly we have seen that with some of the larger enterprises where they got Windows containers running. So the good news is, irrespective of what kind of workloads you're running or where you're running them, managed Kubernetes, self-managed Kubernetes, on-prem, in the cloud, multi-cloud, hybrid, as Andrew mentioned, you can be assured that you can continue to use that common security architecture. And that's really one of the primary reasons folks choose Calico. We have some names listed here, but primarily what we have seen is as folks start to put regulated workloads in their containerized environments, in their Kubernetes environments, that's when some of these problems, some of these use cases that we'll spend a lot of time today, they get more pronounced. And that's really why you see that some of the world's largest Fortune 500 companies, some of the premier financial services institutions of all sizes, cloud native companies, and even some of the largest telcos actually leveraging this technology as part of their containerized environment and the architectures. So that's a little bit of an overview of who Tigera is and what Calico is about. Now, before we go into very specific use cases, it's probably worth kind of just spending a few minutes on the context here. And I suspect for the audience here, the AWS builders, this is not new information. This is no new news. But I think it's fair to say that today, how you are building your applications and how you're deploying your applications is vastly different from what folks would do 5-10 years ago. In the past, folks have deployed applications running on a static infrastructure. Even the application was static. So you could actually design a security or a monitoring architecture maybe after the fact that the applications are deployed or kind of bolt on to your applications. Well, fast forward to today, that approach is just not working and it's not possible. I mean, containers are deployed and the microservices architect, highly dynamic, highly ephemeral workloads that are deployed in an automated fashion. As soon as you check in your code, your CI processes will kick in, they'll build new images, and your CD processes will go deploy, your deployment pipeline will go put those workloads out into the infrastructure. Now, in that architecture, you just don't have any room to manage, monitor, secure, observe these applications out of band. Everything that you're running on, their application architecture, these are all highly distributed applications, distributed infrastructure, distributed operating system. So it presents some very specific challenges around your application, your workload security and compliance and governance and monitoring and observability. So to go into that, some of those challenges, probably worth looking at it from a typical architecture perspective. And I'll preface this with that this is obviously a simplistic view of what your true architecture looks like. But this is just an illustration to convey a concept. And by the way, any of the names and technologies I've listed here, we're not obviously promoting those. It's really some examples we have seen. So let me walk you through what you're looking at. So you could have your Kubernetes clusters running in a specific AWS region. You may have another set of applications running in another cluster in another AWS region. You could have some of your legacy or traditional workloads running inside your data center, or even if it's not inside your data center, some of your databases or your your applications may run inside a cluster. You could have clusters running inside your data center or your in colo providers. And then very often we see that most folks, they start with stateless components running inside their containerized workloads. So there's a data gravity to talk to other non-containerized workloads as well. We've also seen a lot of folks have dependency on API endpoints or cloud services outside AWS in your application. So now if you look at a cloud native architecture like that, one of the first set of architectural challenges folks run into is, or what we've seen is, that your security perimeter or security gateways or firewalls that you may have been deploying, and even if you were not deploying it, your network teams and your security teams were deploying to secure access to these applications, specifically those crown jewel databases that may be sitting in your data centers. They don't really work in this modern cloud native world. And the reason they don't work as effectively is that these firewalls or security gateways, nothing wrong with these devices. They just don't have the Kubernetes workload identity coming in. So for example, let's say a green pod running in a Kubernetes cluster needs to talk to an Oracle database in your data center, or it needs to talk to a cloud API endpoint. But your firewalls won't actually see the red pod, or the security gateways don't see the red pods. They actually see the node, or at best, the cluster from where it is coming from. So there becomes the first set of challenges, that identity is lost. The second aspect is, if you, let's say, design your security rules or your policies or your compliance rules in these gateways or choke points, they don't follow a declarative model. So while your application is getting deployed instantly, you did a code check-in, your pipelines and everything is pushed out, well, your firewall rules may not go in that model. The operating model for those rules or for those devices or those gateways is very different. Different teams manage it, different workflows for that. So that right away creates an architectural impedance for bringing your regulated workloads and driving broader adoption of these applications, of these infrastructure, your Kubernetes environments. Now, if you're wondering, that's great, but how does it manifest from a security and observability perspective? So there's quite a few ways it creates security issues. The first one, I started talking about it. If you have a database running in your data center, and your security teams have said that I need to be able to restrict access to this database to very specific workloads, well, guess what? You won't be able to bring those applications into your Kubernetes clusters, because they want to do very granular allow, deny rules, and their firewalls don't understand that. So that's the first common problem we often see as soon as people start bringing regulated workloads into these containerized Kubernetes environments. The second is you have to assume that at some point of time, you may have a compromise, either coming from a vulnerability, misconfiguration, or any other malware or attack inside your clusters. At that point, it is extremely important for you and your security teams to be able to restrict the blast radius for those compromises. So the ability to manage some east-west controls and protecting the attack surface for your applications is very critical. And then the other common themes that we see or hear from the users is once they do uncover a compromise, let's say you see in your firewall that, hey, there is a attempted connection to a command and control center, or there's an attempted connection to a known bad actor, or you're seeing some signature patterns in your firewall that are just malicious. Well, how do you find out where it is getting sourced from, where it is coming from? And for a good part, they can go undetected, and none of that is a good security posture. Now, the problem is not just from a security perspective. This actually gets amplified when you're trying to uh, uh, troubleshoot or manage a service incident. I'm sure at least some of you have experienced a situation where you got 30, 40 different microservices running in a cluster. You get a service incident from your dev team or your service team that um, we're seeing higher latency in our request, and we're not able to figure out, can you go trace that for us? And it sounds like a simple request. It's not as trivial to find that out. And again, it comes from the fact that you have now your application request going through an entire stack of infrastructure to application across many different distributed components. So if, let's say, you're seeing your application latency go up from 10 milliseconds to 50 milliseconds, or you have a service incident and two services are not able to talk to each other, as a DevOps engineer or as an SRE, it's non-trivial for you to uncover that. You get leaps and bounds of data, alerts, logs, metrics across various different tools you may have deployed or you may be using. But in the end, for you to be able to see why this application or this service-to-service communication is taking more than 60 milliseconds, none of those actually help you a lot. You could have high latency coming from DNS requests. You could have high CPU usage. You could have network congestion. You could have a poorly designed application query. Either of these situations can contribute to performance or even availability issues, and it's not as straightforward to capture those or even troubleshoot that. Well, and then the impact for that is that you now are spending hours, if not days, trying to troubleshoot something and effectively impacting your applications. So that's a very quick summary of the common set of problems that we see as folks deploy regulated workloads as they mature their deployment in the containerized journey. Now, what I'll do now is talk about how some of these challenges are addressed by Calico and Calico Cloud. And really, our mission here is to help the DevOps teams and the SRE teams to be able to secure, observe, and troubleshoot faster in a declarative model, in an automated fashion, so that there is no out-of-band changes needed. So whether you need to implement very granular security controls, or you have a compliance requirement to be able to detect and prevent any kind of malicious activity or intrusion or compromises in your clusters, we are able to do that in a fairly quick fashion. And then last but not the least, the ability to troubleshoot any service issues and performance issues in a very effective and a timely fashion. Now, let me, before we go into live action, let me just kind of walk you through some of these use cases in a little bit more detail. And I promise I'll then pass it on to Nigel to actually show you some of this in action. So if I can orient you on this material on this slide from left to right, really the first set of problems that I was talking about is if you need your applications, your workloads running in your Kubernetes clusters to be able to talk to certain protected environments, regulated environments, which are protected by a firewall or a security gateway, you need to be able to implement very granular access controls for traffic leaving your clusters, passing through those firewalls or security gateways, all the way down to that database. Or if you need the ability to be able to manage secure communication from your green pods to that third-party service that your application needs to consume, you need to be able to write very granular controls. And Nigel will walk us through how some of these can be done very effectively in a declarative model using our DNS policy capabilities and also some of the firewall integration. So that's first aspect. The second is you want to be able to, I mean, in Kubernetes environments, I think you may know this, by default, anybody can talk to anybody. So the entire connection and an entire network space is open. Now, while that's very convenient, it's not very secure. And it is extremely, extremely important that you, as you design your applications and as you mature your applications in those environments, you start to tighten up that security posture, maintain that attack surface. Now, ideally, we would say that you should go into a default deny model where all network access is whitelisted through explicitly defined policies and security rules. Now, that may not be as operationally compliant with where you are today, in which case that's all right. You can start with a very a coarse grain architecture where you can say, hey, my service teams has namespaces A, B, and C, and they should be allowed to talk to each other in those namespaces. But they shouldn't be allowed to, their application should be allowed to talk to these namespaces, which are assigned to a different service team and a different set of applications. So it's really up to you what kind of architecture you want to follow and what journey you follow. But the good news here is that you can actually deploy these rules and these policies, whether coarse grain or very fine grain, in a very automated fashion. In fact, Nigel will show us in a few minutes. We actually have recommendation engine in the system. So you as a DevOps engineer or an SRE, you don't really need to know all the dependencies of your application and design those policies. You can let the system do that for you. We will look at the network traffic, we'll recommend certain policies. You can deploy them in a staging mode, run that for an environment. And if you're not seeing any alerts or any denied packets or anything, well, go ahead and put them in enforcement mode inside your production environment. And without much pain, you now have a well-managed attack surface for your applications. The third aspect of this pillar is around broader security and compliance. So as you start putting more regulated workloads, or as your applications in these clusters need to talk to regulated workloads that may be sitting anywhere else, you know that you will have to go implement certain very crisp security and compliance controls. They could come from a regulatory framework, PCI, HIPAA, SOC 2, GDPR, or whatever compliance controls your workloads are subject to. And you also need to be, and there are various different levels of security controls that we'll talk about some of them. One of the common controls that is around encryption. All communication, all data in transit has to be encrypted. There are rules, policies around having capabilities to detect and prevent any kind of compromises. And we'll walk you through how Calico Cloud actually has a very effective distributed IDS IPS solution. So whether there's an attempt for a communication to a known malicious actor or any kind of attack vectors around IP scans, port scans, we'll detect all of that and will provide you visibility so that you not only are able to manage the security for the workloads, but also able to meet your compliance requirements. And then last but not the least, the fourth set of use cases we'll talk about is observability. So as I was mentioning, when you start with 5-10 microservices, it is relatively simple. But as it goes past 20, 30, 40, 50 microservices and your environments get more complex and you're further along on your microservices journey, it could be really tricky for you to be able to, one, just know what is the dependency between different microservices, who needs to talk to what, and that's important as you're troubleshooting and as you're investigating service incidents. But more importantly, how do you troubleshoot? How do you actually do those very simple things that you've been doing in the past, which is do a simple TCP dump? You can't really do that on this containerized environment in an effective way. You certainly cannot let your service teams enable that. So Nigel will talk to us about how you can actually make that truly self-service. Your teams, your service teams are able to do that effectively. So that's in a nutshell what we will spend most of the time today. All of these capabilities and the use cases, they apply to clusters, environments running in your data centers, hybrid, and so on. And you could do all of this in an automated fashion through your pipelines. So that's a very quick summary of this. Nigel, what I would request at this point is, why don't we start with the first set of capabilities around how do some of these north-south controls could be implemented across Kubernetes clusters. I'll turn it over to you.
And then just real quick
Absolutely.
before we get into that, so for the folks that are just now joining, Gitika, why don't you tell us, who are we, what are we doing here, and what are we talking about today?
Yeah, so today we're
Oh,
going to
everyone
focus.
who's
You continue, sorry.
Everyone's talking about it's all good.
Pause,
I'm
please.
just gonna go ahead and tell everyone we are on Howdy Partner. If nobody knows, it's basically we are from AWS. We have our partners who have innovative solutions come over here. These solutions have already been verified by an AWS solutions architect, and we today have Tigera, and they're going through their solution, which is Calico. And yes, Nigel, go ahead.
Apologies for that.
No,
But yeah,
you're good.
so I'll start by going through these north-south controls. Some people who are joining now might be familiar with some of these features from open source, and then I'll show you maybe the features they're not familiar with already. So I have a cluster open here using Calico Cloud. So the first thing they'll notice is with open source, we don't have this web user interface. Now I'm to simplify the process, I'm going to use a repository here for going through each of the steps.
And then, sorry, Nigel, not to cut you off. Could you make your window just a little bit bigger?
Oh yeah, of course. I'm used to looking at small text.
Nice.
That's perfect. So I'm just going to start off with this product here. Now I won't go through every script, but just to explain, I'm running a bunch of files that are custom resource definitions. You can see here that they are Calico objects. In this case, I'm building a tier. I'm going to call it product, and I'm going to set an order. Now, this is something that won't exist in open source Calico, but it's really just for structure. If we were taking a shift left model, I could have policies ordered by tiers. So in my case, all I want to do is run this simple kubectl apply command, run it in my CLI, and just like that, in real time, you'll see it within milliseconds. It's going to show up now as a new tier within our web user interface. So tiers are really reading policy, as you can see each of the policies here, from top to bottom, left to right. Now, for those who aren't familiar with network policy is a way in Kubernetes. It's within the Kubernetes project. Kubernetes comes with its own network policy implementation, and then we have our own Calico version of that implementation. There's improvements in different ways, but really it's our way of controlling what traffic is allowed in and out of the cluster, or amongst in and out between pods in the cluster. So I've just created a tier. Now I'm going to start creating the policy. Now I think I've created files here. So I have, for instance, a zone-based architecture. I have a DMZ. I should have a restricted zone and a trusted zone. For me to make sense of these policies, I want to introduce an application into the environment. So in that case, I have this storefront application. So actually, that's not the one I'll want. I'll check again. Storefront. And yeah, here's my demo application I'm just going to introduce. Now, the point of this is that we want to show businesses when they have these different services running, how do I have this concept of least privilege, zero trust, so that only the components that should talk to one another are allowed to. So now that I've introduced those new pods, if I say kubectl get pods and focus on just the storefront namespace, I should have a front end, a back end, two microservices, and a logging component. Very simple logical structure. Now I'm building policy around labels. So if you want to show labels, this would be a unique construct here within Kubernetes to say, here are my ways of labeling, understanding what my workloads do. As Amit mentioned earlier, they're ephemeral, pods don't last very long. Therefore, we're not going to build rules based on IP addresses if they don't last very long. So a label we assign to workloads, whether you can see they've got algorithmically generated suffix, whether that changes, we'll always have this fixed logic here in the form of labels. Now we've put labels in here for...
Nigel, I'm sorry. Not to cut you off
Yep.
again. Could you zoom in maybe like 2 more times?
Absolutely.
No worries.
I think that should zoom in. Actually, just 2 seconds. Oh, yes, that should work.
Yep.
Perfect. Does that look good for you?
Yep, we're good. Thank you.
Fantastic. So look, I've put the labels on these workloads and I've categorized them into zones. Like if you're familiar with traditional firewalls, you'll have firewall zones. Like a demilitarized zone would be pods that are essentially front end, should be able to talk to the public internet. Restricted zones, or trusted zones, I should say, are between a demilitarized zone, front end pods, and the back end database. So they carry the data in transit, but they serve no other purpose. So those would be our microservices. And then the back end is logically our database. So it should go into this restricted zone. You shouldn't be able to talk to anything else. Now, building policy can be a complex task because, well, first of all, you want to know that it actually applies to your workloads. And the second thing is you want to know when, again, you're introducing more and more services, that you're not applying a generic task, a generic label structure or schema that may apply to other workloads. So for that, I could normally, in traditional sense, go into the CLI and build a policy. So if I go VI into that DMZ file I created earlier, this is what our policy would look like. Now, there's a few differences with enterprise. We see this ability to specify a tier. So we never had tiers in open source because it didn't have that logical web user interface. It was really just ordering based on priority numbers. So we have this tier object, but more or less, this is the same thing we're seeing in open source Calico. So I'm creating a policy for those who aren't familiar with this. It's a simple logic, but we're saying anything with the firewall zone DMZ, they are allowed to talk to public IP nets, and that's what I'm allowing. And then similarly, I'm denying all other traffic. And from an egress perspective, what talks out from it, I'm allowing it to talk to other workloads, again, not based on IP, this is just based on label, with selectors trusted, or if it has app equals logging. And naturally, anything that isn't in these zones, then I'm going to deny that traffic. So for us, we could just apply the policy here. So I can write and quit, and then I can say kubectl apply -f on my DMZ file. And when, again, like I say earlier, it's Kubernetes native. So when we make these changes, they will be reflected in web user interface. Now, when it comes to observability, why this is so powerful is, as an end user, you can quickly see it applied to the workload I wanted it to apply to. And the reason for it is because it had this firewall zone is equal to DMZ, just like we said inside our rule. If you don't like reading or writing policy in YAML, you can go into the policy board and you can see it in a kind of a humanly readable format. So you can see it in the web UI, here's my allow rule, here's my deny rules, and this is the traffic it applies to. For each individual, let's say, allow or deny or pass action, you can actually see what traffic was allowed, denied, or passed associated with that table or rule. So there's a very logical structure here for observability. Where this goes beyond, let's say, open source, is that you can verify it within the CLI or write this policy entirely from the web UI. So for people who may be starting off there, again, having formatting issues within YAML, or just prefer to have that high-level visibility on how policy is working, what workloads it applies to, and if it's working as we expect it to, the web UI is perfect. And you can always ratify, you can always make these changes within the UI. For instance, if I made a change like not in the CLI, if I did it now in the web UI to say something on the lines of, rather than an IP net, I did it based on label selector, similar to my egress rule. And I said something like, allow it to talk to anything that has the label network equals public. Again, I might not have this object now, but if I was to create it, this key value, and then click save, and I want to, for instance, audit for compliance reasons any changes made to policy, then we can simply enforce or stage the policy. Now, in my case, I'll enforce it. But the reason why I'm doing this is for, again, an organization who's auditing changes and they want to confirm what service account, what LDAP user made a change at what time, what was their change, was it create, read, update, delete? We can always see a change log. Today is the 8th, as far as I know, and there was a file created. Actually, I'll double check here on this policy. There should be a change log. Oh yeah, the most recent example here, that I, the user, ccdemo@tigera.io, made a change to a policy. And just like you would expect in a kind of your text editors when you're comparing version control or in GitHub, you can see the user, in this case myself, had an update action at this time and date, and they removed the public net and they added a new label selector into it. So you can always revert, you can always compare historical timestamps and changes, And again, if this has a negative effect on policy, you can always revert back to an older version. This is something that would be otherwise quite complicated in open source. Now, the major thing here from a north-south control is going back to the topic of IP addresses. So if you're talking about open source, you're still, if you're not doing everything based on label or you're talking to external endpoints, you have to deal with complex IP lists, which are dynamic, they're going to change, and therefore you may need to update CIDR ranges to reflect, again, rules for allowing or denying traffic externally. Now, with Calico Enterprise or Calico Cloud's implementation of network policy, if I were to edit the same policy and I wanted to make an egress rule to a specific domain, not based on IPs, then you can clearly see under our egress rule, there is the ability to add a domain to the policy file. So if I were to say everything that goes to tigera.io, I want to allow that traffic, you can see the ability to use wildcard.tigera.io, and I can say allow by specific, again, ports and protocols. If it's TCP over 443, you can specify that logic here. So there is a lot of advanced configuration you can see in our network policy implementation for allowing or denied traffic to external endpoints. But DNS is a huge piece. That ability to keep control over what traffic you're allowing and denying, but of course, simplifying it rather than focusing on complex IP lists. Definitely DNS policy is a huge advancement here in web user interface. And if you ever want to ratify and confirm what changes applied or before you apply them, you can always just download the YAML from the web UI before you enforce it, and you can always see what that policy would have looked like. You can see I'm still using a trial version of Sublime. So yeah, that's definitely from an egress perspective, really powerful. But that's just for our front-end pod. If we wanted to build this kind of micro-segmented workloads per pods within a namespace, then I could apply the other three files. So I had the DMZ example there a second ago. So now I just want to add the trusted zone and the restricted zone. So just like that, I can run kubectl apply on the hosted files. I hosted all of these files in my GitHub repo, so you can go to the same repo. It's public hosted, so there's no reason why you can't try these out yourself, test them in your own environment. But as I say, this is Kubernetes native. So as I run kubectl apply on these policy files, then we're going to see this show up in the web UI in milliseconds, close to real time. We know that it's working on our workloads because it shows on the endpoint view, trusted matched my two microservices, and similarly, restricted matched my backend pod. And you can see that under the endpoints view. So that's one way of managing policy around in our implementation here. One of the other things that's really neat around kind of automation and better understanding workloads is if I introduce, let's say, a new application into our environment, and I'll go through this one in a little bit more depth in a while, but if I were to introduce, say, this boutique store application, many people might be familiar with this one. It's used in a lot of different projects, but kind of a shop application. So as I introduce all those new workloads into my environment, I can quickly see that in our web user interface as those new pods that are being thrown into the default namespace. So all our workloads are now showing up in here. I'll go on to the host protection in a short while. But under our default namespace, we now have a front-end pod, Redis, cart, all of the things similar to what we'd expect with the storefront example. But let's say I have no label schema like I did here with the nice little structure of front-end pod, back-end, and intermediate pods that have zero trust, and anything that isn't in this zone structure will get denied. And I want to build similar fine-grained policy. Well, we have a bunch of observability features in the solution, and the ability here even to just drill into where the packets are going in our environment, say in the default namespace, which I just introduced workloads into it, and I were to pick on any one of those new pods, let's say the front-end pod that's in here, or the ad service, for any one of these pods, we can then look at where the existing flows are, and we can use policy recommendation as a way to say, from the existing flows we've identified for that pod, we've seen it talk to other pods over certain ports and protocols, you could suddenly have a very fine-grained network policy implementation without any knowledge of previously developing network policy. And this is something for sure you can't do open source on its own. So yeah, I guess there is a use case here, for organizations as you're learning. to try that out. But if you're unfamiliar with any of the concepts I've shown earlier, policy recommendation is a great way for you to kind of see where your traffic's going, not just in observability, but for recommending a fine-grained policy to only allow the ports and protocols that are talking between the workloads inside your cluster.
So Nigel, if say you are just starting out with the product itself and you are not really sure how exactly things will flow, so you deploy Calico and then you let it do these visualizations and then make the decisions. Is that what you're saying?
More or less, yes. And if you're ever unsure, like I'll give a good example. I should have a namespace that came along earlier called Acme. And let's say hypothetically, I don't know anything about that namespace. So if I was to get the pods in the namespace Acme, I would have a microservice 1 and microservice 2. But if I knew nothing about them, even the label structure, and I'm throwing all my trust in a product, policy recommendation is a great way from not just visualizing the traffic, but recommending a policy. And I don't have to enforce it. Say if I go to policy recommendation and I look over the last 15 minutes traffic or a longer period of traffic, I can use it as a kind of a guideline for how policy should be designed and how zero trust should be developed in our organization by only allowing the pods that talk to each other, like the microservice 1 and microservice 2, so that it would identify from flows that these pods only talk to these other pods, like here ingress, egress, or only talk to microservice 2 over port 8080. And if you're unsure of how that will affect your cluster, you can also stage policy. And stage is a way for us to easily identify how it would have applied to existing traffic without it actually enforcing that traffic. So definitely, I believe this is a good way for organizations who are starting off a policy and trying to implement zero trust if they've never done it with Kubernetes before.
Yeah, I agree. I feel like you shouldn't be testing it out in production because I have seen numerous times people just breaking things down just because they're trying out some security group, just playing around with it, and just everything goes to hell. But thank you so much for that.
No problem. Perfect. So I think I went through most of the north-south examples. One that I didn't have prepared for this session, but it's a fantastic use case, is going through our egress gateway. So with pods, not having fixed IPs and them being ephemeral and by nature, you can kind of have a dedicated pod with a fixed IP. And the idea behind the egress gateway, or a namespace with a fixed IP in it, is that if you were trying to interface with external endpoints, again, it could be a SIM or some kind of syslog server, and it needs to talk to Kubernetes over a fixed IP, you can design that through the egress gateway. We use the concept of universal firewall so that it can do that firewalling against those endpoints, again, for setting the rules of allowed or denied traffic. But more or less observing the DNS denied or allowed traffic and then being able to extend on our network policy implementation in open source is perfect there. Amit, is there anything you'd like to go through next on the offering?
No, this is great, Nigel. And I would just add to what you said, true story, fellas. There is an actual scenario where a customer was looking to add 1,960 firewall rules to implement their security zone architecture through those firewalls. And the examples that Nigel took, in fact, it was those same YAMLs. You create some of those policies, and voila, you got those rules built out into 14 different clusters without having to go through those weeks and months of manual workflows. So that's really the power of this declarative model and an automated fashion that Nigel just walked us through. Now, a couple of things I would add before we switch to the next topic is that, Nigel talked about how you can use policy recommendations and the preview mode. One of the key sets of capabilities is that, as I was talking about, you may have multiple clusters and you may need federated capabilities across different environments. So I don't think Nigel will be able to show us those federation capabilities, but one thing that's worth at least mentioning here, that as your environments grow, you got clusters across different, you got workloads across different clusters. with Calico, Calico Cloud, you are able to federate both the identity of the application across different clusters or also the policies. And in very simple words, what this means is that if you want to write a policy that red can talk to green, well, red and green could be sitting in different clusters, and Calico will take care of that. So that's another key advantage, because sometimes these problems, they get much more complex as you're looking at a multi-cluster scenario, and folks try to build a Krugi architecture to support those. You don't really need to do any of that. Keep it very simple, routable network, and use federation capabilities, and you can implement any of those scenarios. Now, Nigel, we talked about all the policies and different scenarios. One of the key things that I believe we should talk about here for Calico Cloud is some of the compliance capabilities and some of the advanced IDS, IPS functionality. So I'm not sure if you're set up today, but would love to walk through these users, how they can see some of those capabilities where, let's say, there is a rogue workload inside the cluster, or whether there is a compromise. How can they actually detect that, and more importantly, do something to quarantine or restrict access to that compromise through various capabilities here? So would be great if we can show some of those scenarios to our AWS folks here.
For sure. So I'll start by sharing again. And what I'll do is I'll introduce that rogue workload into our cluster. The idea being here is that workload, we should be able to automatically catch it and prevent it. Now, when we were talking about earlier, this tiering concept, a lot of organizations will throw out this shift left idea. I mean, you hear it a lot, is making security ops come before DevOps. So what I've tried to do is order my tier of security before product. Now I'll introduce a policy. Again, I'm going to go in here and I'm going to look for quarantine, and I'm going to apply it so that it's a security best practice before any other traffic is allowed. So yeah, I'll just run another kubectl apply, and this is on the new policy for quarantining. Now this policy is pretty straightforward actually to understand when you see it. It's saying anything with a label selector quarantine is equal true. I'm going to log and deny the traffic, whether it be ingress or egress. I'm quarantining quite literally. So it's a bit different to how you would imagine it with an AV tool when it goes into a file, that's isolated and it strips it of its payload. In this case, we're using network policy to simply deny the traffic. So even if it tries to generate it, we'll even log it so we keep that forensical history. Now, at the moment, if you see in our pod list or in our endpoint view, I have this storefront namespace, but it's just the standard applications. Now I could introduce this rogue pod anywhere, but for visualization, I thought it'd be nice to introduce it into storefront. So I'm going to pick the rogue workload. And again, I uploaded all these to this repository. So if I want to introduce the rogue pod, you can see here, I'm going to run this YAML manifest and I'm going to add it to the storefront namespace. So just like that, when I add it, and just to verify, I'm just going to run kubectl get pods on the storefront namespace, which I think I ran a short while ago. We should then be able to see there's a new pod called attack wrap. So there it is, attack wrap. Now the pod's creating in 2 seconds. That should already be created. And as we say, it's Kubernetes native. So when we go back to the web user interface, we should now have the storefront namespace with the attack wrap in it. And it has, again, some labels, and we can see what node it's running on. Now this pod, what it's going to do is perform a bunch of TCP port scanning against other pods in other namespaces. So this issue isn't isolated to a specific namespace. This could be anywhere in a cluster, or it could be trying to talk externally. Now what's nice about an observability solution is being able to visually identify when, say for instance, an alert is triggered on this storefront name, and the reason why is that a pod is talking to a threat feed. Something we've classified an IP list as a threat feed, and I'll show that in a second how we do that. So this is really going into our IDS, IPS capabilities, is identifying what workloads are rogue and how they're talking to these external endpoints. But when we go into the namespace, you can see the individual pods. And more importantly, it hasn't been, oh, there it is. So it's just taken a few moments for the traffic to be generated for this one. But what green and red showing us is if pod traffic is denied, it's red, green is allowed, and this is based on policy. So it's actually my microservice 2 here that's speaking to an IP represented in this list. And for those who are interested in IDS, IPS capabilities, the first bit here that's really cool is our concept of threat feeds. So I'll just go back into the here and we'll just go to threat feed just to show the example. I can actually open up the YAML manifest here and we'll pick on the, actually, I'll go back to the anonymization section. Yeah, so you can see here, I've got this Tigera VPN. So for anyone who was, let's say, talking to a command and control server, they would want to maintain some form of anonymity, because if they don't, obviously, we know who they're talking to or what IPs they're talking with. So they'll go through like the Tor network, preferably, and they'll go through this EGR VPN feed, a long list of IPs and CIDRs, and then in return, they go through this Tor exit feed. Now, those feeds, they have nothing to do with Tigera as a company, but we can subscribe to the feed to build network policy. So you can see here, we got this global threat feed. That's one way of preventing a rogue pod from talking to a command and control server. We can use this custom resource definition for Project Calico. I've just given a name of EGR VPN. We're making a pull request against a HTTP URL, which is just this text file here. And again, it's maintained by a third party. This could be updated every day or regularly, it doesn't matter. And there's really a huge list of IPs. And so this could, it could be an IP list associated with malware, ransomware. Again, in our case, it could be to do with Mirai botnets. But in those scenarios, we just convert it into a global network set object and give it a label of EGR VPN. And why that's so powerful is in the case of our network sets, it will then show up in our solution as this IP list and CIDR ranges, and we just have to label as feed equals EGR VPN. Now, since it's a label, we can do the same thing we do with other workloads. We could make a network policy to say, deny workloads in a specific namespace from talking, or deny pods with certain label selection from talking to IPs associated with this feed based solely on a label, as opposed to, copy and paste the list of IP addresses. So that's a really powerful way for having firewall-like capabilities of denying based on IP without you maintaining the list yourself. You just have a pull request against that HTTP address, and then you've got your feed there. But for the rogue workload, let's say it's run rampant, and again, we can see that in our service graph. We'll start seeing red lines coming from storefront as the pod starts trying to talk to other endpoints. Now, at the moment, it's talk to a Tigera internal. That's a good point. We'll mention this in a second, because we have this capability of creating decoy pods. So we call them honey pods, like play on honey pots in traditional Linux networking. So with those honey pods, these fake decoy pods, they could be a vulnerable MySQL image or an Nginx image. If this pod, this attack wrap, tries talking to one of the pods in that Tigera internal namespace, which is where the fake pods are running, it will trigger an alert telling us some SSH attempt was performed, and I'll check under my custom alerts. But here it should tell us, some privilege attempt was made against a file, or you can see, here's my vulnerable image, the MySQL instance. Attack wrap tried communicating with that vulnerable image, and we know it was running in the Tigera internal namespace. So there's ways of triggering alerts that are pre-baked into the product, so that if there is unusual behavior, whether it's anomalous behavior, so you got anomaly detection jobs running, or if you have these honey pods running, fake pods that would kind of lure that potential rogue actor into trying to do data exfiltration, and will see it, alert on it. But let's say now I know for sure, aside from the being called attack wrap, I know that's a rogue. So for me to quarantine it, it would be as simple as going in here and saying kubectl label pod, and then I could grab the pod name and give it the label selection of quarantine is equal to true. So I could say quarantine pod with, quarantine is equal to true. Now, as I said earlier, this is all Kubernetes native. So when we make these changes, label, I have to specify the namespace. So we know it's in storefront. So that's perfect. So I've labeled the pod with quarantine is equal to true. So if I run the command earlier of get labels or show labels associated with it, you should now have quarantine is equal to true. Now, why that's so important is when we go back into our web user interface and you see quarantine, although it's not showing any denied traffic now, it certainly will in a second, because the rule was saying deny everything, whether it be ingress or egress, as long as it has the label selection as true. And we know our workload is quarantined. You can start seeing the denied traffic, and it's applying to attacker app. Now, I very much did that manually. I used, well, it was somewhat automated. I had alerts, I had feeds to tell me it's reaching out to unusual IPs that was showing up in the service graph. There was the alerts triggering, it's again telling us there was unusual SSH attempts. I have much more alerts actually triggered on this other cluster. So things like if there was, attempted SSH connection from that pod, or if you're seeing unusual port scanning behavior from that pod, again, all those conditions are baked into the honeypods, so that if a rogue actor tries doing data exfiltration against that, what seems to be a vulnerable image, we're alerted on it. We're aware that there's something going on that I wouldn't allow or permit. And now we've either performed an automation effort or we've done it manually. But either way, our pod is now labeled and it can't, it's isolated. It can't perform any actions now in our cluster. So that's one way of both observing the traffic, alerting on it, and staying compliant by, of course, locking down those rogue workloads.
And then just real quick, and so I was reading a little bit more about kind of how the platform uses eBPF technology under the hood to help support some of these capabilities that you're talking about. I know eBPF is something I'm still learning about myself and diving more into it and just learning more about how it can help improve security postures within Linux and Kubernetes environments. Could you maybe just explain to me kind of how eBPF is being used in this particular use case?
Yeah, so in the use case I actually outlined there, that would have worked the same for standard IP tables implementation. So when people are talking about standard Linux with kubeproxy and IP tables, that would have worked fine. Similarly, if you were developing network policy implementation and you had eBPF as your control plane, we would still be able to support that. I guess where eBPF is kind of an exciting topic, and I say kind of when it is an exciting topic, is that it gives you this kernel level control to kind of write in hooks, again, for specific functions. So it could be a security hook, or it could be a networking related hook. But these are kind of allows us to write essentially mini programs to either get more out of it or have higher performance. Like where the performance comes in with eBPF is essentially skipping or no longer needing kubeproxy. So if kubeproxy is a big kind of performance issue, then of course bypassing that is fantastic for those who have highly distributed workloads and again on scale, and they want again any bit of performance gain. But I think regarding security, those hooks are definitely the exciting piece. But regarding policy, it will work the same for eBPF as it does with standard Linux IP tables.
Solid.
Cool. One point, and I didn't get a chance to really demonstrate it at this point, but you may see that we can build policy around VMs as well as standard containers. And all of the workloads I've focused on so far are containers. For those who spotted it a while ago, I actually used a concept like auto host endpoint protection. So I've created pods associated with my nodes. So as you can see here, if I actually show namespace to a global namespace, I have 3 node cluster, and these are standard EKS managed nodes. But again, they're not in a namespace because they're not containers like these other workloads. They're Linux hosts. But since I've converted these into host endpoints, like pods associated with hosts, and I'm able to label them with specific context, like is it etcd or is it a worker node, or what does this workload do? Since I labeled them, I'm able to do the same thing I do with standard workloads. I can build a policy to say, allow or deny traffic for any nodes that have the label etcd or environment is equal to this. I may not have done this example yet because I actually don't see the labels already added to my host. So an easy way to do this is in my repo, if I go down to host endpoints, you can, I think I already patched it, so that shouldn't be an issue. But really, I would just do 2 things. I'm going to label all my nodes. So if when I run kubectl get nodes, you can see I have 3. I want to label all of them with Kubernetes host equals, which means that there's simply Kubernetes host, and I've got the label added. But the other label I wanted to add specifically was, what is the environmental purpose? So I could run something like, we'll say here, the master example. I know they're all worker nodes, but in a different environment, if you're, again, managing work control plane and etcd and all these different nodes separately, I could run something like this. Of course, copy the name of my node here. So I can just go back quickly and give it the environmental variable of environment equals master. Again, this is just a label. But once I've added it, as you can see here in the policy view, there we go. The endpoint is matched. And as you can see, it's not a standard pod. It's actually a node. So that's the host type. And I can build a similar rule to say, just like any other policy, allow TCP port 443, or in this case, actually deny anything that's not 443. And, you can go and have the same granular level of policy control. So for those who are interested in maybe having use cases for allowing or blocking specific ports on a higher level, not on specific workloads, but on the host level, we do support that as well within Calico Enterprise and Calico Cloud.
So
Perfect. Mason, is there anything you wanted to go in specifically, or is there any questions about what I've shown so far?
Nigel, this is great. I was hoping before we jump to observability, for those of our DevOps engineers who hate to add 5-point stories in their sprint because audit is coming and they need to create 30 screenshots from all those tools that they are using, can we do something for those folks, or can we show them something how to actually generate compliance reports and evidence data so that they don't have to burn their entire sprint taking screenshots?
Yeah, 100%. So compliance is a painful job, especially when it comes to, say, PCI compliance. You're handling payment details, and pretty much every organization today is in some shape or form. So when you have those PCI compliant workloads, you, depending on how many, of course, payment transactions you're handling, you may have to provide monthly or yearly. It depends. There's going to be unique scenarios, but you're going to have to generate these kind of compliance reports. Now, it's one thing doing it manually, as you say, screenshots, compiling all your raw data, and then if you don't have access to that, that's the big pain point. So if we go into my GitHub repo and I skip straight to compliance, I kind of built 3 scenarios, and I actually have 4, I think, in total. I also have this audit log example, but we'll focus on these 3 here, and I think I can generated all of them already. So I'll just do a wget on this. So you can do network access, or in this case, you can do CIS as well. So for those who aren't familiar, CIS is the Center for Information Security, and they kind of generally set best practices for your worker nodes on kind of security hardening. So are you adhering to these best practices? For network access, that's really going to be the main point for compliance, is to say, okay, are our pods able to talk to other pods that are not, let's say, PCI compliant? Therefore, you might be breaking compliance. They can be scheduled. So in the case of CIS, I'll show you there. If I do VIA onto that CIS file, here's our custom resource definition for global report. And as you can see, I have the ability to schedule this. As you can see here, I have the schedule value set in my specification, and it's using cron syntax. So I could modify this if I wanted to say, right now it's generating a report every hour. If I wanted it like every day, did that work correctly? I don't know. Oh yeah, there, that works better. So you can specify like hour, day, weekly, monthly, yearly in those values. And then again, because it's scheduled, you don't need to manually run this report every time. It will then have an automated report schedule sent to you, and you can use it for maintaining compliance to show your auditor, here I'm maintaining best practice. Now this is CIS specific, so it's got number of failed tests that I'm going to include into this report, but I'm just going to leave it pretty standard. So yeah, even this one, if I write it, it's going to now be daily. But I don't need to run kubectl apply in it because I've actually already added these before the session, because I need at least an hour for these reports to show up. Now under compliance reports, you can see here, I have my CIS report. It's showing up here. And for the security hardening, for sure, it's showing me a bunch of failed tests. I created this cluster, I think, yesterday. I've done nothing special with it, but a lot of businesses are going to do the same thing. So you can export these CSV outputs that are generated, and then I can open this up in Excel if I want. But once I have those CSV outputs, let's say I want to look at my failed tests, it won't just show you for an auditor, okay, you failed. Like security hardening is no good if it just tells you you fail things. It's better for it to have remediation steps on how I can go about improving security posture. So it lists clearly, here is the worker node that has failed the test. This is what they failed on. So some anonymous authentication argument should have been set to false. I know to pass that test, I need to set it to true. But either way, the remediation will go through how I need to restart kubelet and make these changes. So that's really cool from a security posture perspective. But most people now, if they're trying to stay compliant with, again, PCI or could be with HIPAA compliance, again, it's the same rules really apply, is confirming workloads can't talk to other non-approved workloads. And as a result, you can have this network access report to tell me if I failed or not. Similar idea, I can export the CSV report. I can build up again, a lot of people do this. They just build up a directory of all my historical failed or passed tests to show compliance over time. But either way, even from the web UI, you can see in these nice little visual graphs to say, I have so many endpoints. This isn't even necessarily has to be for your whole cluster. You can scope it through specific PCI or HIPAA workloads or namespaces, and then show of those pods in those namespaces that have to maintain compliance, how many of them are protected from an ingress or egress level by network policy. So if I'm failing these compliance reports, well, first of all, I need to go back and revisit my network policy implementation. But either way, it's scheduled, so I always have a historical trail of what those audit results were. Cool. Is there any questions there?
I also had a comment. I've worked with a lot of customers and partners that that need to go through things like SOC 2 reviews. Obviously the ones that you just talked about, and it's not easy, and it gets really complex really quickly. So to be able to have these tools at your disposal, honestly, will make your life so much easier. Because before these tools and solutions existed, I mean, you can only imagine the number of man hours that people were spending just to get these reports together, right? And even through that process, they probably still miss things because it was such a manual process. But honestly, now with these tools and solutions, like, why wouldn't you use this at your disposal, right?
Yeah, and Andrew, just to attest to what you just said, true story. I can't name the user or the customer, but a DevOps team of 10 people, 30% of their capacity, their DevOps capacity, gets consumed into collecting this evidence data, audit data, when a time comes for their SOC, a sheer wastage of time and resources, while they have a huge backlog of infrastructure-related items or whatever else they had on their roadmap. But it's a big pain point that we have seen with our users. Great. So I think we're probably on our last leg of this this show today. We talked about how you secure the workloads, how you drive compliance, how do you create evidence data. So hopefully you got tens and hundreds of microservices running in your Kubernetes cluster. And as soon as you have that, the problem now is, how do you actually visualize and troubleshoot? So Nigel, there are various capabilities in Calico Cloud that help the DevOps teams and the SREs on just base visibility around which services are talking to which services, and walk us through about what they can expect and what they can leverage from Calico Cloud on really just troubleshooting and figuring out how to where the problem or pain points are or performance issues are in their cluster for their workloads.
Yeah, absolutely. So yeah, there's quite a lot to go on here from a troubleshooting perspective. So I'm going to share my screen and we'll go back into my cluster. So yeah, I'm just going to clear on that. So the first thing I would say is I'll introduce a new workload, a new application into our environment if I haven't done so already, and it seems like I haven't. So or maybe I have the boutique application. So why I'm picking on this boutique application is that it has a nice front-end pod. So if I said kubectl get svc-a, I should have the IP address of that front-end external pod. So I'm just going to grab that and I'm going to access that in my browser. So for a lot of organizations, they've probably gone through this process of saying, I want to make sure my application is running, that I can access it and that everything works correctly. So if I just say port 80, I think I might have to specify. Maybe not. Let's double check. Maybe it's this 30. Let's double check. And I'll double check that it needs to be HTTPS. We'll double check if it's working correctly. But yeah, okay, it's coming up. So this is a standard test application. It's got a front end, it's got a shopping cart, it's got all these components, and I know they're working because they show up on my web user interface, or my browser. So if I said kubectl get pods in the default namespace, you should see each of the pods, and again, the status is running. So that's how people on a high level would see all the components are working the way they should. Now, Calico Enterprise or Calico Cloud will give you far more options with regards to troubleshooting if one of these pods stops working. The first way is, say, in regards to the policy implementation, I introduce, so I'm going to go to the boutique again. I'm going to introduce a policy here that what it's doing is it's going to just simply block the traffic. So you can see here, deny front-end pod traffic. And for those who want to see how this policy is designed, again, you can access in the repo. So I'll just say wget on that file, and it's called front-end deny. There's a typo there, but it doesn't matter. So front-end deny. And what it's saying is anything with the label at front-end, apply these rules, allow and deny traffic. It's very simple. Now I'm going to quit that there, and I can say kubectl apply-f on the front-end deny YAML file. Again, the policy is created. It should be in my default namespace or default here. So when we go back here, you would quickly see here front end. It applies to that front end pod that we expected in the default namespace. And obviously troubleshooting, you quickly see the traffic will be denied. One way of testing that is if I go to my test application, if I can not access the front end face, I think it's broken here. So if I try to go to the landing page, it won't load and it's probably going to crash. And I can prove that if I try and open it on another page, it's down. So I've denied the traffic. That's how people are going to troubleshoot the problem. And sometimes it's far more complex than this. Like an easy way to fix it is you would go into the UI. I can see that the traffic is being denied, and I can say, oh, it's being denied because I blocked it by policy and it's scoped to this endpoint. I better fix that. So I have a scenario for this. I can run, instead of kubectl apply, I could run kubectl delete. That will remove the policy I just created, and my application should suddenly be working in real time. So I go back here, try to load the page, and it should just appear. So that proves that policy is not the problem. So we'll try one more time. But the policy should be deleted, and now I can access my front-end application. Now, let's say you've got a highly distributed environment. I could then say, well, an easier way to troubleshoot, I seem to have been logged out. That's not, I will log back in. But when you need to troubleshoot, let's say, disparate issues, so I'm going to log in with that email address, and I'm just going to grab my password, which is always at hand when you need it. You may need to do dynamic packet capture. Now, the thing about dynamic packet capture, why it's so important is, rather than execing into the pod that you want to know from a networking perspective why it can't, again, there's a DNS issue or something specific, you don't want to keep execing into pods. You might not have elevated permissions to do so, and you really have no visibility of what the problem is. Of course, our service graph, we have a service graph that gives you the full view of everything in your organization. So when we look at our service graph, we can see all the pods that talk to all the pods, and that's a great starting point. You know, you can quite literally see, here is a pod. If I want to troubleshoot it, I can see it makes inbound, outbound requests to other pods, and they are being denied by policy, much quicker than the example I showed earlier of going per each policy to see the traffic is denied on that pod. Is it denied on, let's say, TCP port 443? We'll have all the supporting data. Now, all of these graphs are populated by essentially aggregating flow logs. So all of the rich metadata, we can aggregate it, whether it be source IP, destination IP, source ports and labels, all of it's there. So you've got all the context to build something really powerful. Now we have a Kibana integration. So if we want to start with DNS and see, is it a DNS issue? You could go into our DNS dashboard, which is pre-populated, and that will give us kind of some of the context as to what could be happening or where the problems are coming from. So you can always just go into the dashboard view. As I say, this comes with Calico Cloud and enterprise licenses. So if you want to look at, say, layer 7 HTTP traffic via Envoy integration, or if you just natively want to look at layer 3, layer 4 traffic, in this case DNS, we'd have the dashboards to say where the traffic is being denied, and again, what are the external domains that you're trying to talk to, and how many connection attempts are established here. Now, for me, it could be a DNS issue, but either way, I want to use Wireshark, I want to do TCP dump, and I really want to get a better understanding of what's going on. So if we go into my repo, I have a dynamic service graph or packet capture. I'm just going to go through it step by step. So let's say I have here, I should have no pcaps. So I'm only just checking to see if there's a pcap in the home directory, and there is no files that end in pcap. So with that, what I'm going to do is I'm going to apply a new, again, custom resource of Calico. So if I run wget here, I'm going to try and show you what that's doing, and it shouldn't have an X at the front. So I'll just remove that X. So this custom resource, what it's going to do is it's going to specify a specific namespace where my issue is coming from. So my issue could be in the default or it could be in storefront. We can pick it here. So if I run I'm going to run a VI on that file. So it's called packet capture. You can see here it's another Calico object called packet capture. And I'm just giving it its own name called storefront capture because I'm going to capture anything in the storefront namespace that has the selector app equals front end. So we may have quickly looked at that a while ago about my pods in my different namespaces. So I can say kubectl just for the purpose of demonstrating -n storefront, and we want to see the labels. I have my front end pod, and it's the one I'm focusing on here because it has app equals front end. So we know the labels, we're going to apply that to our example here. So actually, what did I call my file? It was called packet capture. So I'm going to say kubectl apply -f packet capture. And that creates the packet capture. So as you can see here, packet capture has been created. That's good. It's going to start doing packet capture on the again, Kubernetes concepts there. Like we talked about labels and we talked about specific namespace. We've got some granular context here that we're starting to do a capture on. Now, once I'm ready, once I've done it, I can check that the capture actually has been created. So I'm going to do kubectl get on the packet capture. And then it tells me, look, you've got that storefront capture. It's just been created. Let's stop that capture now. Let's have something that we can actually work with. So I'm going to delete that same capture definition that we just created. And the reason why is that's just going to kill the actual capturing of information. So now it's deleted. I should still have the packet. So if I want to check for the pcap file, it's a matter of saying, well, first of all, check that the capture is there in the storefront namespace because that's the scope that I established on it. And it should show me I have a maybe kubectl get packet capture in storefront namespace. Maybe I didn't specify namespace. -a. Oh, I don't know why that didn't create. We created it, then we should have been able to. If I double check here, ls. Do I have my dynamic packet capture? No, I only have the file. Let's just try that one more time. So if I go to create the capture, again, we specified the scope for that capture. It is created. it should be inside the storefront namespace. Okay, yeah, it's there. So when I delete it, yeah, so it should be there. So we checked that, that's fine. Then I want to delete it. Oh yeah, so that's fine. So we can delete it and then we should have our captures. That's okay. So when I go back, just to clarify, I've already run, I've got this kubectl binary. So what I want to do is I want to use this object of captured packets to copy it over from storefront namespace. That's it. So again, whoever has RBAC elevated permissions to do this, they can carry the file over. So I should move this now over to the storefront namespace. Or yeah, it's moved into my default directory. So when I do ls, now I have this PEC capture called frontend pcap. Now for me, if I want to read it, I can use a tool like Tshark. So again, for those who haven't done it, I put in just kind of guide there for running sudo yum on your standard Linux nodes, Amazon Linux, and then you can use it. So in my case, I've got a packet capture. Obviously, it's going to have a unique name. So for that case, I'll want to, first of all, copy this over. And I'm just going to put that here. And then I want to copy this example here. And I'm just doing grep on it just so I can focus on individual components. So I want to make sure that I'm using the correct pcap file, not the one I put in my example. So we'll just swap that out. And as you can see, I'm using the Tshark tool because I want to look at DNS traffic associated with that. And Tshark, command not found. Let's double check that I've installed it correctly. Sudo yum install Wireshark. And that should install all the components associated with it. This will just take 2 moments. But why we're showing this example, although it might look confusing in the beginning of just getting into place, it's a rather straightforward process. And compared to, I'm sure most of the users here have gone through this in past, capturing traffic, then needing to analyze an external tool, or even just remoting into those pods again, especially in complex environments, it's a rather tedious task. So in my case, now you can see what I can do. I can use Tshark now to analyze that pcap file. I've even grep for microservice 1 if I don't want to grep at all for anything, or if I want to look at, say, the second service, let's say I'll spell it correctly, you can then see the traffic explicitly for that. So it's really easy then to, once you've created the object, capture the traffic, you can delete the object, you've got the packet, you can move it over to a default directory, and you can do that across your environment. So it's a combination of using the graphs to easily see where the performance degradation occurs, either between any of the supporting metrics we're giving you, such as latency, request count, seeing performance anomalies within the actual web application, but then being able to use dynamic packet capture against any namespace or labels rather than, again, needing to keep track of what pods are being ripped up and down. You can use static constructs like labels and namespace. So very easy way of troubleshooting with dynamic packet capture. And I hope I demonstrated that to some level here. So yeah, that would be the best way of troubleshooting with Tigera.
Great, thank you, Nigel. So I think that's a little bit of a glimpse of everything that you can get from Calico Cloud. So starting from just base set of segmentation controls, some policies, then some security rules. We saw an attack pod deployed, and we did the quarantine for that pod. We went through some compliance reports, and then last but not the least, we went through how you can get some service level stats and dependency across your applications, your microservices. And then very last piece that Nigel just went through is how do you actually do some kind of troubleshooting tactics, things that you've been doing in the past using traditional packet captures, which are very, very hard and complex to do in this microservices world, since you don't have access to the nodes. So that's what we went through. Excuse me. Hopefully all of this was helpful and relevant. And I'll give it back to our host, Andrea and Gipika here, for any questions or final remarks.
Yeah, I actually had a quick question. So I think you touched on an important point in that, a lot of people that may have been using Kubernetes from the early days may already be managing all their manifest files, configuration files, or whatever have you, in something like Bitbucket or like GitHub. If you're someone that's doing that today, but you want to adopt something like Calico Cloud and use that for things like observability and things that we talked about in today's show, what additional steps would that person need to take in order for Calico Cloud be able to pick up any changes that are made to the manifest files that live in GitHub? Because I know that you showed an example of how you can download a YAML file of a policy that you create within Calico Cloud. But if you're someone that manages all that via something like GitHub, kind of what does that process look like? And do you have any best practices for someone that would like to move over to using the Calico Cloud platform?
Yeah, absolutely. I can start, and then Nigel, feel free to add or Ian, correct me if I say something that is not what we see. So, Andrew, typically what we see our customers do, and I would recommend that as a best practice, just like you have your code check-in into your code repos, typically they would have a config repo as well, and that's where they have all their YAML files that define the policies, these different things that Nigel went through. And really what you want to do is your deployment pipeline should pick up code and also your configuration files and deploy it as part of that process. So while for today we went through a user interface and Nigel went through some GitHub examples, but in a steady state, in a production deployment, all of that should be automated as part of your favorite pipeline tool and incorporated there. And Nigel, I'll let you add anything or correct.
Yeah, no, absolutely. So that's a good point. Like we showed very much a simple example of doing it manually, either through a web user interface for newbies or going through the CLI if you got more experience writing those manifests. But you're correct in saying if you want to write it entirely or push deploy through your CI/CD chain, then that same API is accessible for the chain. So that we have users today who don't use the web user interface and they certainly don't write the YAML and just made those changes manually, they're automating the entire process of deploying network policies. So it's definitely flexible for the large infrastructure or automation approach, as well as for people who are starting their Kubernetes journey.
It's good to know. Aside from that, since we're kind of right on the topic and because we're kind of using EKS for the demo environment, you guys also have a CNI plugin for folks that are using EKS. Can you maybe talk about that a little bit and kind of how that plays into all this?
Yeah, absolutely. So actually, for the purpose of the presentation today, I chose to kind of create a default cluster with EKS using the AWS VPC CNI. So for those who, let's say, are already using a cluster and already have VPC CNI and they're worried, oh, do I have to conform to using Calico CNI? Absolutely, you can continue to use network policy in the same way you can do your general networking within AWS without the need to change CNI. Where Calico is maybe a flexible option, as Amit mentioned earlier, is being a pluggable data plane. Our CNI works with eBBF implementation with standard Linux, which a lot of organizations are still using standard Linux with IP tables and kubeproxy. But even for organizations that maybe have a specific use case around Windows workloads with H&F data plane, then for them, they may say, okay, actually, we may have a specific use case where we don't want to use the default AWS VPC CNI. We'd like to use Calico CNI for those networking challenges. But without, whether you use AWS CNI or the Calico CNI, you can still implement this fine-grained network policy and it won't challenge the organization.
Nice.
Interesting.
Cool. Other than that, one last question I had for myself is, do you guys have a public roadmap that people can follow for, upcoming changes or features to Calico Cloud or anything else that you guys are working on?
So, Andrew, we do not have a public roadmap that we have published, like on a GitHub or something.
Sure.
However, we do report and process some GitHub issues purely from our Project Calico GitHub. If folks have feedback for us or want us to work on something, I would strongly encourage them to file GitHub issues there, or even better, just reach out to us at this email address that we're sharing here, and we will be more than happy to answer those questions.
Awesome. All right, Yika, do you have any questions or comments for our friends over at Tigera?
Just one. So we do see a lot of solutions which are into monitoring and compliance. What do you think is unique to Tigera, and like how does it stand out in the market?
Yeah, absolutely, Geetika. So one of the common issues that most users run into is that they gotta apply or deploy 2, 3, 4, 5 different technologies to achieve
Right.
some of the outcomes we talked about. But more importantly, each of these agents or daemons that running in your cluster, they all consume resources, they all consume capacity. And then at the end, you still are left with trying to stitch the information together and actually connect the workflows. And I feel like that leaves a lot of work for users to do those things themselves, and it's time consuming, it's resource intensive, and really doesn't hit the outcomes for them. And that's fundamentally the big differentiator or the benefit with exploring Calico in those environments is you got a tool set that actually helps you with multiple of your use cases and scenarios, whether it's troubleshooting, security, compliance. And it's not just us. I mean, there are third-party data available that talk about how Calico is one of the most performant solutions among our comparisons.
Yeah, that's great to hear. I think I was pretty impressed by the UI. I know that I'm not good with YAML myself, and I was so happy when I saw the UI. Okay, I can just go in, check all these boxes. There are recommendations already there. I think that was pretty convenient overall as a solution. I was really, really impressed today.
Great.
Awesome. Sounds good. So I guess just to recap, so kind of like how I started the episode, now that everyone here has seen like how much easier this can be by using Calico Cloud and some of the different products that Tigera offers, I would definitely highly recommend checking it out. Like I mentioned before, like this is how I learned about network policies and why it's important. And honestly, since then, like the product suite's gotten even better. And if you're not using something like this today, you're just making your life way more difficult than it needs to be, quite honestly. So I really want to thank my friends over at Tigera, Amit and Nigel, for doing a demonstration on Tigera, Calico Cloud, and the importance of security and observability within your Kubernetes workloads. If you guys want to learn more about kind of what they're doing, we will include some links in the chat that you can follow to learn more about kind of what they're up to. But other than that, Nigel, Amit, thank you so much for hopping on the stream today. Really appreciate it.
Thank you so much. Thank you for the opportunity.
Sounds good.
It was a
And then
pleasure.
other than that, we're here every Wednesday, 2 o'clock Pacific. So tune in next week for another episode of Howdy Partner. But other than that, we're signing off. Thank you, folks. Appreciate it. Take care.
Thank you.